Hey guys, what's up? Let us start with the next lecture of the question and answer series. First question is most important paleontological evidence for the existence of Gondwana land is the occurrence of. I am sure you all must be knowing the answer. It is Glossopteris flora. Uh, Foraminifera, trilobites, and graptolites. So these examples do not hold here because Gondwana land it is the age which is considered is the Permo-Triassic, and each time period has its characteristic fossil. So had this answer not been given here, instead if it was written somewhat like reptiles, then you should have put the answer as reptiles, because as I just said, each of the time period has its characteristic fossils. So the correct answer here would be Glossopteris flora, no doubts about that. Next question. Which of the following isotopes would be most useful to study the Earth process that has time scales of 1,000 years? Now, whenever we are looking at a question like this, first of all, it is very important to see what is the time scale asked. It is 1,000 years. This question would have been other way around, as in they would have given the half-life in the question, and they would have asked what time scale does an isotope with this half-life would give on using it for dating. So whenever we have this time scale of 1,000 years, we should understand that we have to go for the best answer, and the best answer here would be C14. Let me tell you something about C14. C14, it is a radioisotope of carbon, radioisotope of carbon. And how it is made? In the atmosphere there is the nitrogen nucleus which has 7 protons and 7 neutrons. Now this nucleus, it is hit by thermogenic or thermal neutrons which are generated from the sun. When they hit it, they knock one proton out, and then this neutron comes and sits in here. The resultant is a nucleus which consists of 8 neutrons and 6 protons, and we all know that a nucleus which has 6 protons is that of carbon. Therefore it becomes C14, which is radioactive, and this carbon has a half-life of 5,740 years. So let us say how it can be used for this time scale of 1,000 years. Now imagine that lead, which is showing a half-life of 22 years. So can we use it for studying up to 1,000 years time scale? So let us calculate. So if let us say we have 100 atoms of lead which has a half-life of 22 years, so in first 22 years it will become 50, second 22 years it will become 25, next 22 years it will become 12 and a half, next 22 years it will become 6.25, next 22 years it now becomes 3.125, next 22 years it now becomes 1.5, 6.5625. Now we can see here that 1, 2, 3, 4, 5 and 6. So 22 multiplied by 6, it becomes 132 years. So in 132 years, this lead, it would reduce from 100 atoms to 1.5 atom. It means that when the half-life is less, the amount which can be precisely read by the machine it becomes very small, and then it may not give you the data which is very accurate, and therefore we cannot use this lead for 1,000 years time scale. When we look at tritium, which is H3, it has a 12.5 years life scale, so you can apply the same logic. Now when it comes to uh, potassium 40, then here you can see the half-life is 118 million years, which means that 1,000 year time scale will be very small when we use this K40. So it's also not precise to use K40 for 1,000 year time scale. As a result, the correct answer would be C14. Next question. The Paleotethys Sea once separated. Now we all know that the Paleotethys, it was separating the Laurasia, and it used to separate the Gondwana land, and this was the portion which we used to call as Paleotethys. So this will be the correct answer. These are all questions which you should remember. These are very common questions. So let us see this. If you see this picture, you can see here that this portion is the Gondwana land, this portion is the Laurasia, and this is what is the Paleotethys. So it's an easy question. The oldest rock reported from India dates approximately. This answer you can get by logic. The logic is that this is the Earth's age. This is the Earth's age. So this cannot be the answer for this question. Definitely this cannot be answered because Earth is much younger than 8,000 million years. We all know that 2,500 million years is the age, or is the time period which separates the Archean from Proterozoic. In India, we find both. So this is, we should write here. This is the Archean, Proterozoic boundary, in which is the age of 2.5 million years. Sorry, 2,500 million years. Now in India, we find both the rocks, Archean as well as Proterozoic. So the cratons in India, they are the Archean rocks. The mobile belts, they are the Proterozoic. The Purana basins, they are Proterozoic. So logically also, the correct answer is 3,500 million. This is how you can derive the answers. Compared to the Earth, Jupiter orbits around the Sun much slower because of its lower density, higher mass, larger distance from the Sun, slower rotation about its axis. We have already done one question like this regarding Mars. So if we look at the solar system, and if this is the Sun, so we have Mercury, Venus, Earth, Mars, then comes Jupiter. So if we just draw two planets over here, this is, let us say, Jupiter, the largest planet with the maximum number of satellites. So this is a gas giant also. So we can see here that the orbit which it is covering in the process of revolution around the Sun is much longer, and since the distance it is covering is much longer, therefore it is much slower. This will be the correct answer. Which of the following molecules is most buoyant in the atmosphere? Carbon dioxide, water, N2O, and ozone. We all know that the correct answer to this would be H2O. Write in the comment section how H2O is most buoyant. Okay, it's a very easy question, you all can guess easily if you apply some uh, prior concepts of molecular mass, buoyancy. Okay, which of the following contributes most to the heat budget of the Earth's surface, radioactive heat from the rocks, internal heat of the Earth reaching the surface by conduction, volcanic eruption, and solar radiation. We have already done one question in the previous lectures. All right, so the correct answer to this question would be solar radiation. We all know that the heat budget of Earth is contributed to the maximum by the solar radiation. This question is quite easy and you all must be knowing it. Next is bauxite formation is an example of metal enrichment by extreme crystal fractionation, mechanical concentration, chemical leaching, and gravity separation. Those of you who have read ore geology in your BSc and MSc classes, they must be aware that whenever we are talking about the metal enrichment, then the first process that comes to mind will be the super gene sulfide enrichment or enrichment. Okay, supergene enrichment. Now this process of metal enrichment is an example of chemical leaching. So we all understand one thing over here, that the uh, chemical leaching, where active or chemically active groundwater or volcanic water or whatever meteoric water, they react with the already existing ore or the mineral, and then by this reaction we get different other minerals which comes into picture and enriches that ore deposit, sometimes also referred to as the process of metasomatism. So with this background, I am sure you will must be getting the answer that it is the enrichment by chemical leaching. All right. Now this is an important question. In which portion of a meandering river channel are the coarsest sediments deposited? So what it is asking? It is asking about a meandering river channel, and this meandering river channel, we all know that if let us say this is the river meander, then on this convex curve the river, it erodes, and on this portion it deposits. So if you look, if this is the stream flow direction, so this is how it is eroded from this portion, it is deposited from this portion. Now let us look at the options: crevasses play, natural levee, channel Thalweg, and channel margin. Let us have a look at these diagrams. If you look over here, then you will understand that in a meandering river system, we get these point bars on the concave part, while the erosion portion is on the convex part, which is the path of the deepest water flow. Now crevasses play, it is, sometimes when the flood in the floodplains, when the river floods, the river bank, it breaks off, giving rise to a splay like deposit. It spreads just from the main stream. So this is channel crevasses splay, which is of course which cannot have the coarsest sediments in the uh, meandering channel. Now natural levee, we all know that the natural levee is on the floodplain, this way. So floodplains over here, this is the natural levee, which of course cannot be the coarsest sediments. Now we have two options, channel margin and channel Thalweg, and the correct answer is the channel Thalweg. So if you look at this, what is this channel Thalweg? Channel Thalweg is this path where the in which of the portion of a meandering river channel are the coarsest sediments deposited. So when we look at a meandering river channel, then we all know that if this is a meandering river channel, then in the convex portion, if this is the path of the river, this is the portion of erosion, and the concave portion is the portion of deposition. The options given here are crevasses play, natural levee, channel Thalweg, channel margin. Now, when we look at these four options, then first of all we should know what do these mean. So crevasses play. Crevasse means it's just a fracture or a broken portion. So from the main channel, if let us say this is the main channel, and on the banks of the river this portion breaks off and the water spills over here, brings in our sediments over here, this is called as crevasses play. Natural levee, I had already explained in one of my previous videos. It's if this is the floodplain and this is the river channel, so these are the natural levees. What is channel Thalweg and what is channel margin? So this is the channel margin, and the channel Thalweg is the line that joins the deepest portion of the channel where the water level is the deepest. So if we look at this diagram, in this diagram of a meandering river channel, we can see the point bars, they are in the concave portion, which is the place of deposition, and this is the portion of erosion, and this is the Thalweg. It is the path of deepest water flow. So it is asking in which portion of a meandering river channel are the coarsest sediments deposited. So that you can understand that if this is the channel path like this, and here it is the portion of erosional bank, it is the depositional bank. So let us say the coarser sediments and the finers, they are broken from here and the finest are over here. Now what will happen, that this water, it won't be able to push the coarsest sediments over here further. As a result, they get deposited in this portion of the stream flow where the water level is the deepest. So the answer to this would be channel Thalweg. Match the following. This is a very common question from the geomorphology. So it says evaporites, deflation, sandblasting, weathering, streamlined hills, and the options on the other side, they are ventifacts, desert varnish, playa, desert pavement, and yardangs. Okay. Evaporite deposits, we all know what are evaporite deposits and how are they formed. Extreme uh, evaporation can lead to formation of evaporite deposits, and the best answer to this would be playa. What about deflation? Deflation is a type of aeolian weathering and wind erosion. So in deserts, we all can see the deflation platforms where the high velocity winds, they remove the finer particles and the coarser ones, they remain over there, and therefore we get the desert pavements. Sandblasting, whenever the you might have seen some videos on YouTube where people try to clean some portions of any material by using a sand gun. So when they blast sand, so coarser sand particles with very high speed, they kind of polish that surface on which they hit. So sand blasting leads to the formation of ventifacts in the deserts. Weathering weathering, we all know what is weathering. It is the breaking down, or it is the breakage of the coarser fraction into finer ones, and When this weathering continues for longer time, what we get is the desert varnish, and thus it leaves us with streamlined hills. They are yardangs. So the if we go by the options, the correct option is 1. Have a look at this diagram. So this is what you see. This is playa, first one. So this is playa. This is desert pavement. Desert pavement. So here you can see how the finer ones are removed because of the deflation. This is sandblasting. So this is a ventifact. Sometimes we also called it dry canters when all the three sides are polished. So let us say this was a pebble like this. The wind carrying sand started hitting from here, and this surface got polished. This is called as ventifacts by sandblasting, and these are yardangs. They are streamlined hills, so you can yourself see how this can be answered. Oh, again, match the following. So here we have Bajada, Drycanter, Karn, Dolines, and we have Aeolian, Desert, Glacial, and Karst. So, what do we understand from over here? That we have to match the process by which these landforms are formed. So, let us look at them one by one. So, what about Bajada? Bajada is a kind of uh, compound alluvial fan, or it is a Piedmont alluvial fan, which is commonly formed under the arid or semi-arid conditions. And then when several alluvial fans they coalesce together, they make up the Bajada. What is a dry canter? Just now we saw one question on the desert landforms where we saw ventifact. Now, what what is it that we can call as a dry canter? So, dry canter is a ventifact with three polished sides. Now, that brings us to Karn and Dolines. Have you heard these names, Karn and Dolines? If you remember your physical geology classes of UG and PG, then you will understand that Karn and Dolines they are the landforms which are formed by the or basically they are the weathering landforms or erosional landform, to be more precise, erosional landforms. So when we look at the erosional landforms, then the dolines they are formed in the karst area, or because karst topography is associated with limestones, so a doline is a bowl or a cone shaped depression in limestone areas. And how they are formed, they can be formed in number of ways, but of course all of these it uh, leads to the same thing, that is the karst topography. So dolines, this now we got D as S. Now what about Karn? Karn is a glacial landform. What about Drycanter? It's Aeolian landform. Yes. And then Bajada is a desert landform. Arid conditions are formed. So we get this answer. A Q, B P, C is R, and D is S. Okay. Which of the following landforms of glacial erosion and deposition is not streamlined? So when we look at this question, uh, when we call about the glacial, and when we talk about the glacial landforms, we have to look at the landforms which are streamlined, means they are in a line. So If we look at them one by one, so whaleback, drumlins, and roches montanese, they are the landforms which are streamlined. You can look at their diagrams in the uh, on the internet and various books, and the correct answer would be ground moraines. So ground moraines, they are scattered, they are not well sorted, and that is why they are sometimes also referred to as erratics. So ground moraines are the glacial features which are not streamlined. So we have understood this question on erratics. Let us now look at the next question. Which one of the following is in the increasing order of bathymetry? Very easy question. We are being given three uh, geometries: the continental slope, continental shelf, continental rise, continental shelf, continental rise, continental slope, continental rise, continental slope, continental shelf, continental shelf, continental slope, continental rise. So to answer this question, you all should remember this diagram always. This is the ocean bottom structure, and this is the sea level. So this one, this is the beach, this is the shoreline, and then we have the shallowest portion as continental shelf, then we get the continental slope, and then we get the continental rise. So we can see the bathymetry. What is bathymetry? It is the water depth. So we can see here that shallowest will be the continental shelf, followed by slope and then rise. So increasing order of bathymetry will be fourth. Okay, it's very easy question. You all should remember this diagram. Which one of the following currents of Indian Ocean is not a seasonal current? West India coastal current, East India coastal current, South equatorial current, North equatorial current. Okay, so if you look at the map of the ocean currents of the world, then you should understand that there are two kind of ocean currents. Because they are all surface currents, there are two kinds: permanent ocean current and seasonal ocean current. So of these given options, if you look at this peninsular map of India, here we have the Bay of Bengal and here we have the Arabian Sea. Now these are two currents. This is called as East India coastal current, and this is called as West India coastal current. So these two currents, they are seasonal currents. They are driven by the monsoonal winds. Okay, monsoonal winds. So this is the direction when the southwest monsoon comes in. Sorry, northeast monsoon. This is the direction of these currents when northeast monsoon comes in. If we have to look at the if we have to look at the southwest monsoon, then this is the direction during the southwest monsoon. So these two cannot be the answer: East India and West India coastal current. Now if we look at the option number 3 and 4, we can understand that yes, the these two currents seem to be permanent current, but in case of Indian Ocean, what should be the answer? So let me try draw and show you. So if this is the equator and this is Indian subcontinent, this is the Indian Ocean. So this is the direction of south equatorial current and this is the direction of north equatorial current. During the southwest monsoon, sometimes when the
winds become very intense, they block this north equatorial current, and then it either completely diminishes or it becomes extremely weak to be noticed. Therefore, north equatorial current also acts as seasonal current in the Indian Ocean, while south equatorial current is a permanent current. So the answer to this question should be this one, third one. South equatorial current is not a seasonal current of the Indian Ocean. Rest all three, they are the seasonal currents. Which one of the following is not a dominantly interannual phenomenon? Interannual phenomenon, the options are ENSO, that is El Nino Southern Oscillation, Indian Summer Monsoon, Madden-Julian Oscillation, Indian Ocean Dipole. All these ENSO, Indian Summer Monsoon and Indian Ocean Dipole, they are interannual phenomenon, while Madden-Julian Oscillation, it varies on a scale of week. It's a weekly to monthly phenomenon. Read about Madden-Julian oscillation. So this the correct answer here is Madden-Julian oscillation. Read about it and write in the comment section what do you understand by Madden-Julian oscillations. Very important phenomenon as it works in the case of ocean atmosphere linkage. Rest ENSO, we all know El Nino Southern Oscillation is a quasi-periodic phenomenon, occurs on the scale of every 3 to 5 years. Indian summer monsoon is an annual phenomenon, it comes every year. Indian Ocean Dipole is also an annual phenomenon. While Madden-Julian Oscillation is a quick pulse and it's a weekly to monthly phenomenon. Alright. Which one of the following is a thermally indirect cell? It's a very important question. Hadley cell, Ferrel cell, Polar cell, Walker cell. So first of all, we all should reject this answer, Walker cell, because we all know Walker cell is a typical of the Pacific Ocean and it definitely is a thermal cell. Now let us look at the three main cells of the wind belts where atmospheric circulation. So Hadley cell, Ferrel cell and Polar cell. So let us look at the Earth. Suppose this is the cross section of the Earth. This is the equator. This is 30-degree latitude. This is 60-degree latitude. And this is 90-degree latitude. I'm drawing only for the northern hemisphere. So, and this is the tropopause. So when the air rises, now why this air is rising? Because this air is warm and moist. That is why it becomes the coolest air. The lightest air, and it rises. So when it rises till tropopause, then it diverts, gives rainfall, comes to 30-degree latitude, becomes cold and dry, and becomes heaviest, and therefore it sinks. So we get the Hadley cell. So for Hadley cell, what was the first thing that was important? It was the heating or temperature. Now let us look at the polar areas first. We all know that 60-degree latitude is the temperate latitude while 90-degree latitude is the polar latitude. So if we compare the temperatures of these two latitudes, let us imagine that at the temperate latitude the temperature is -1 degree Celsius or temperate and subpolar, while at the polar latitude the temperature becomes -30 -40 degrees Celsius. Now, we all know that -1 is greater than -40. So, we can say that the temperature of -1 is warmer than temperature of -40. I hope you understood this, that the temperature of -1 is greater than the temperature of -40. Now, what will happen? So the poles, they will be at a high pressure while this area will be at a relatively lower pressure. The wind goes from high pressure to low pressure. So this will be the direction of the wind. We see a rising arm, we see a returning arm, and then we see a sinking arm. This is the idea behind the polar cell. So what was the basic concept behind the polar cell? The temperature again. So in case of headless cell, it was the warm temperature, while in case of polar cell, it was the cold temperature. Now when we look at the area between 30° and 60° latitude, so what will happen? At 30° latitude, the air that is sinking, it is the cold and dry air. As it hits the surface, this air diverges. One part goes towards equator, this one, while the other one it travels towards the 60° latitude. At the same time, the air which is coming from pole, बहुत ध्यान से सुनिएगा, listen to it very carefully. At the same time, the air which is coming from pole to 60° latitude is cooler. ठंडी है हवा. As a result, this air and the air coming from 30°, so we have two air masses colliding. At 60° latitude, we have two air masses colliding. First one is which comes from 30° latitude, and the second one is the one that comes from 90° latitude. So the air coming from 90° latitude will be cold, and therefore this air, it will be heavier. It will be heavier. फिर क्या होगा? So the air that comes from 90°, since it is heavy, it will push the air coming from 30°, because the air coming from 30° is light and it is buoyant, मतलब वो हल्की है और उसकी buoyancy है. As a result, we again get this uh, air mass which rises, goes up to tropopause and then diverts. So I hope you understood why the feral cell, how the feral cell is generated. So we saw here that the generation of feral cell has the main factor as the air masses, heavier air masses and the pressure gradient. Therefore, feral cell is an indirect thermal cell, or it's a thermally indirect cell. Okay, you have to keep in mind just this fact, that for headless cell the warm temperatures were responsible, for polar cell the cold temperatures were responsible, but for feral cell it is the mass of the air which is coming and the buoyancy which is causing this air to rise. Okay, all right, I hope you understood it. How does El Nino influence atmospheric CO2 levels? CO2 decreases due to increase in primary production. CO2 decreases due to weakening of equatorial upwelling. CO2 increases due to increase in the mixing of upper ocean. CO2 increases due to the increase in heterotrophic respiration. To understand this, let us first look at the what is El Nino. So during El Nino, why does El Nino even occur? It's because trade winds, they become weak. The trade winds, they get weakened. As a result, the equatorial currents, they get weak or diminished. Okay, it's a quasi-periodic phenomenon occurring every 3 to 5 years, and due to the difference between the islands of Darwin and Tahiti in the Pacific Ocean, the El Nino occurs. Now, when El Nino occurs, what happens in the Western Pacific and Eastern Pacific? If let us suppose that this is equator, this is the coast, this is South America, this is the coast of Peru and Chile, while this is Australia. So, when El Nino occurs, the Western Pacific warm pool water shifts to Eastern Pacific, making the entire Pacific Ocean warmer. As a result, this current, which was known as the Peru current or Humboldt current, it becomes weak. No upwelling. So let us look at the options. CO2 decreases due to increase in primary production. Now tell me something. How can primary production increase when there is no nutrients? So the first option is wrong. What about the second option? CO2 decreases due to weakening of equatorial upwelling. It seems right. CO2 increases due to increase in the mixing of upper ocean. How can the upper ocean mix when the trade winds are weaker? So this is again wrong. CO2 increases due to increase in the heterotrophic respiration. Now this seems some logical, but you have to understand that this increase in CO2 due to heterotrophic respiration, it is highly unlikely, because the maximum population of the animals which do heterotrophic respiration, it is very less as compared to the phytoplanktons which live in the surface water. So the phytoplanktons, they do photosynthesis and they always check the concentration of CO2. So this be, even though it is correct, but it is not the very logical answer. So for this question, uh, the correct answer is CO2 decreases due to weakening of equatorial upwelling. How come? See, whenever upwelling happens, the waters from deep ocean or the thermocline waters, they come up. What do these waters contain in them? They contain carbon dioxide, because they are coming from deeper oceans where there is no photosynthesis, only respiration and decomposition. As a result, this water when comes up brings up CO2. So when this upwelling, equatorial upwelling, will be arrested or it will be seized, then this will cause a decrease in the atmospheric CO2. Okay, so the second option is the correct option. Next question is a very interesting question. Chlorofluorocarbons, which were widely used in refrigeration, catalyze the breakdown of water vapor, carbon dioxide, oxygen, and ozone. So we all have read in our school days that CFCs, chlorofluorocarbons, they are the reason for ozone layer depletion. Now this is a school level science, but do you know how these CFC, they break down oxygen, ozone? So there is a very good article. Just type on Google 20 questions on ozone. It's an excellent article. There are 20 questions, very pertinent questions, which can be asked to you in any interview. So you should read. Write in the comment section how do you find this article, 20 questions on ozone, and you will find the answer to my question, how CFC break down ozone, O3. And in this you will also read something about reactive halogens. Try to read about this and do write in the comment section what do these mean. Okay, all right. The delta 18O value of modern seawater is 0 parts per mil, while the average value of that of polar ice cap is 45 parts per mil. The ice cap holds 2 weight% of total water on the earth. What is the delta 18O value of an ice-free ocean? Alright, now what we can do here, I have told you one such question in one of the previous videos. So right now I'll be only telling you the answer. I expect you to solve it, and do write in the comment section if you face any difficulties in solving it. The correct answer is minus zero point -0.9 parts per mil. You have to solve it. How you will solve it? Go to the previous video, see what I have explained over there. See, this question is a bit different than the previous one, but the logic applied here will be the same. Okay, so solve it, tell me. All right. It's a very interesting question. Two paleo ecosystems A and B are being compared for their species diversity. While A is represented by 5,400 individuals, 50 species, B has 2,000 individuals and 45 species. Using the rarefaction curve drawn with assemblage A, identify the correct conclusion. Alright. So before going to the options, let us first look at what the question is asking. The question is talking about two paleo ecosystems and their species diversity. Remember, there is a difference between individual and species. Now, what it is saying? It is saying 5,400 individuals, while how many species? 50 species. So it is quite possible that out of these 5,400 individuals, it is quite possible that they are evenly distributed among 50 species, or a few species would be more dominant than the rest of the species. So if you look at this rarefaction curve, it says that there are 50 species and 5,400 individuals. What about B, Paleosystem B? It has 45 species and it has 2,000 individuals. So if we try to draw it, uh, then how it can be drawn? Let us say we make this line over here, and we make a line over here, and then we draw this rarefaction curve. This is for B. So you yourself can see that in case of A, the number of species and the total number of individuals, take out the ratio. So if we calculate it as 5,400 is to 50, and then we calculate 2,000 individuals as to 45, then what do we get? We get that in case of A, the number of individuals is higher, and of course species is also good, it's 50 species. But when we compare it with B, we find that the number of individuals is much less, and as compared to that, the number of species is still very high. As a result, what we can say? We can say that when we compare the two paleo ecosystems and we compare these two rarefaction curves, we find that A has the A has lower species diversity than B. So what is the correct answer over here? The third one. I hope you understood this. Okay. All right. Let's go to the next one. The following is a list of important events in organic evolution. First appearance of mammals, first appearance of fishes, first appearance of birds, first appearance of flowering plants. This question can be answered if you have read the geological time scale properly. When you type in Google the geological time scale and open the Wikipedia page, then they have given in a great detail uh, of the events that have occurred over last 4.5 billion years. So you should read the pertinent. First of all, read about geological time scale from Wikipedia. You will get all those important events and then try to memorize them. It's a university level, graduation level question. So when did the first mammals appear? Does anyone know? The first mammals, they appeared during Triassic. Yes, during Triassic. When did the first fishes appear? They appeared during Devonian. What about birds? They came in Jurassic. And what about flowering plants? They came in Cretaceous. Cretaceous. In Creta, they came in Cretaceous. So, okay, so let us now look at the options. So the first will be oldest is fishes, that is B. So we strike out 2 and 4. Second is A. So this is striked out, so that we get the first option as correct option. There are several such events. So these are the pertinence was asked in this question. They may ask you based on the Precambrian, when did the first oxygen come in the Earth's atmosphere? Uh, when were BIFs or BHQs formed, like that. So you should read about the geological time scale is correctly. It's very important. Any geology student should learn the GTS by heart and should have a fairly good knowledge about the events that have occurred on the earth. All right, which one of the following river patterns is more common in Precambrian successions? Very interesting question. Braided, meandering, anastomosing, straight in Precambrian successions. So a braided channel would be, this is a braided channel. Okay, this is a stream direction. Meandering pattern is very easy. So this is the erosional bank, this is the deposition. So these are the point bars. Anastomosing, it looks very much like the braided channel, but that just that it's, bars, the braided bars over here, they become very large, and a straight channel is this. So the question here is, which one of the following river patterns is more common in the Precambrian successions? The correct answer is braided. Now why braided was very common? The braided pattern during Precambrian succession was very common because there was no rooted vegetation. Rooted vegetation. So what does this mean? Means there were no large trees. So when there will be no rooted vegetation, let me draw for you. When there will be no rooted vegetation, then what will happen? Let us say that this river is flowing. Okay, and there is nothing on this side and nothing on the either side. So what will happen now? There will be a very strong runoff, because to stop the sediments, the trees and vegetation is not there, so the runoff will be there. The bank collapse, the river bank collapse is there. Bank collapse is there. So what will happen? The river will show a lateral migration very frequently. Lateral migration. So this river now can shift here, then river may shift here. As a result, all the sediments of this area, this area, they may become a part of the main river stream. So while the channel migration is very frequent and the runoff is very high, the sediment input in the meandering river makes it more braided. We all know that when the sediment supply becomes higher, a meandering channel it shifts to the braided pattern. So I hope you understood that due to the lack of rooted vegetation, which encourage the lateral migration of the channel very frequently, the most common river pattern in the Precambrian succession was the braided one. In which of the following condition relative sea level rises? Eustatic sea level is rising and basin floor is uplifting at a faster rate. Eustatic sea level is falling and basin floor is subsiding at a faster rate. Eustatic sea level is falling and basin floor is stationary. Eustatic sea level is stationary and basin floor is uplifting. This question is the first basic question when we talk about the sequence stratigraphy. So let us first have a look at uh, what are the various options where the basin and eustacy. So we have two things, eustacy and then tectonics, which play an important role in an important role in sea level rise and fall. So let us look at this basin. If this is a basin and this is the sea level, so this is the basin floor. Now let us say that the sea level starts to rise. At the same time, the basin also starts to sink due to tectonics. So what will happen? This will increase the accommodation space, and therefore this will be the event of transgression, that is sea level rise. When the sea level starts to rise, but at the same time the basin also starts to uplift. So this is the sea level which is rising, and this is the tectonic uplift. Now what will happen over here? There are two scenarios. If the rate of sea level rise is greater than tectonic uplift, then it will be a transgression. But if the sea level rise is slower than the tectonic uplift, then we have a regression. So see how the relative sea level comes into picture, that when in both the cases sea level is rising and the basin floor is uplifting, but if the sea level is rising faster than the basin floor, it will be transgression. So meagerly rising of sea level is not transgression, keep that in mind. Similarly, let us say that the sea level is falling and the basin is getting, subsiding, subsidence is happening, then what will happen? Again, if the rate of fall of sea level is more than the tectonic sinking, then it will be a transgression. Oh, sorry, it will be a regression, because the sea level will fall. While if the rate of sea level fall is much less than the tectonic subsidence, it will be a transgression. So here you saw that the water levels were falling. Still, if the basin is sinking at a faster rate, it becomes transgression. So this is the basic idea. And one more scenario is there, when it's a very simple one, when the sea level is falling and basin is uplifting. In this case, it will definitely be a regression. So let us go back to the question. The question says that in which scenario the relative sea level will rise. So eustatic sea level is rising and basin floor is uplifting at a faster rate. So definitely water level will not rise, it will fall. Eustatic sea level is falling and basin floor is subsiding at a faster rate. Yes, this will be the and this seems the best answer. Now what about the third one? Eustatic sea level is falling and basin floor is stationary. Definitely not, because if the basin floor is not changing, sea level is falling, it will result into relative sea level fall. And eustatic sea level is stationary, basin floor is uplifting? Of course not. Because water levels are not changing and you uplift the sea floor, it will be again a relative sea level fall. So the correct answer will be the second one. Is it clear? Yeah, next. In the table below, identify the correct pair. Plate boundary type example. So, if before going to details, let me tell you, I have made a video on Wilson cycle. Go through that video. You should learn the table given at the end of the Wilson cycle, that at what stages, what process, and what are the examples. Okay, so we have the juvenile phase, the adult phase, sorry, the embryonic phase, juvenile phase, adult phase, mature phase, and old phase, and the last one is suturing phase. So each of these, they have different processes, different tectonic processes. You should read about them. It's a very, very important question about Wilson cycle. So let us now look at this. Plate boundary type is oceanic divergent, continental divergent, oceanic continental convergence, continent convergence and transform. And the example: San Andreas fault, Himalaya, mid-Atlantic ridge, East African ridge, and Andes. All right. So this is one way of asking the question. In another way, they may give you these examples, and they may give you the stages of Wilson cycle: embryonic stage, juvenile stage, mature stage, adult stage, suturing stage, old stage. Okay. So you should remember all those. So let us look at this. So oceanic divergence, we have the mid-Atlantic ridge. We all know that, correct? Continental divergence, East African rift valleys. These are opening up. The East African rift valleys, they are opening up. They are now currently in their embryonic stage. Then the oceanic continental convergence, the Andes mountains. Yes, the entire Andes mountain chain is uh, is the result of the convergence between the between the uh, Pacific plate and the American plate. Yeah, you should uh, try to analyze that. Continent convergence, very easy. Himalayas, the Indian plate collided with the Eurasian plate. It was a continental continent collision. The continent convergence of and giving rise to Himalayas, it represents the suturing phase or the terminal phase, not terminal, suturing phase. Not the terminal phase is over. It's the suturing phase, last phase. And the transform fault is the San Andreas fault. We all know that. So the correct option here is 1. Read about Wilson cycle. Tell me if you have any problems in the comment section. Identify the clastic material on the basis of grain size distribution of some samples from different environments. Now, this is a very, very important question. You must have read about, so in how many different ways this question may be asked. You must have read about the in your sedimentary about the Wentworth scale, Eden-Wentworth scale, then the applications of the kurtosis and skewness. If not, please do revise. These are very, very important topics. Now, look at this frequency and look at the grain size distribution. So, we go from 256 mm to 1 upon 256 mm. Okay. And out of these four, how the uh, environment will vary. So, if we look at A, B, C, and D, we can see that uh, there is a decrease of grain size from boulders to the stage of silt and clay. Now, when we look at A, then it seems to be a very coarse grained environment, followed by, so it's medium sand, or normally it is sand. So we have the cobbles, pebbles, at A. Then we have sand size particles at B, followed by fining sand, and further going on to silty clay type of deposits. So if we look at these, we have A as shingle beaches, B as sandy river channel, C as dune sand, and D as loess. Did you understand why this happened? So to understand this question, you have to first tell me in the comment section, what is a shingle beach? First one, what is a shingle beach? Second, why the sandy river channel will have coarser sand, coarser sand than dune sand? Why sandy river channel has coarser sand than dune sand, than the dunes? Okay, So tell me in the comment section, and we can discuss on it later. But the correct option is third one. Next, in the plan of stream network, the bifurcation ratio of first and second order stream segments is, okay, this is again a very easy question. You must have read about it in the uh, geomorphology class. This is also sometimes referred to as Strahler's method. Strahler's method of stream ordering. Of stream ordering. All right. So, do you know how to order these streams? Let us order them. One, first order, 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 first order. So how many first order streams do we have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 first order streams. What about second order? We all know that when two first order streams join, we get a second order stream. So this is second order, this is second order, this is second order, this is second order. Yeah. All right. So how many second order streams do we have? We have 4 second order streams. So now let us take the ratio. The ratio would be 2.25. What about the third order stream? So when two second order streams join, this becomes the third order. This becomes the third order. Third order. Okay. And what about fourth order stream? When two third order streams join, we get the fourth order stream. So this is again a fourth order. But what about this joining? That a first order stream is joining a fourth order stream. So in that scenario, the resultant stream will be the higher order stream. So if a first order stream and a fourth order stream join, the resultant stream will only be a fourth order stream. Okay, this is a very simple question. Which one of the following condition is not required for tropical cyclone development? Vertical wind with weak vertical wind shear, moist unstable air, warm ocean surface water, zero Coriolis force. Since we have discussed a lot about such type of question, the answer will be zero Coriolis force. Understand the question, read it properly. Not required for cyclone development. We need a Coriolis force for development of cyclone. So zero Coriolis force is not required. All right. Subtropical gyre is driven by equatorial easterlies and subtropical westerlies, equatorial westerlies and subtropical easterlies, subtropical easterlies and polar westerlies, subtropical westerlies and polar easterlies. And I am pretty sure you all know this is the correct answer. The subtropical gyre. Let us take example of subtropical gyre: North Equatorial Current, Gulf Stream, North Atlantic Drift or North Atlantic Current, and the Canary Current. So we have the equatorial easterlies. Let me draw equatorial easterlies. What is the other name for equatorial easterlies? Please do write in the comment section. Okay. So these are equatorial easterlies and these are subtropical westerlies. Okay, so you have to tell me which winds are also known as equatorial easterlies. Okay, all right. Which one of the following statements is not correct? During glacial interval, delta 18 O of benthic foraminifera shows higher values. During glacial interval, delta 18 O of benthic foraminifera shows lower values. During interglacial interval, salinity of ocean decreases as compared to glacial intervals. During glacial intervals, the delta 18 O record of ice core shows lower values. Of course, when we look at this question, we have to understand the facts. So it is saying, first of all, not correct. So during glacial intervals, delta 18O of benthic foraminifera shows higher values. Of course, it will show higher value because The benthic foraminifera, they are bottom dwellers and they are more affected by the uh, ice volume effect rather than the surface sea surface temperature. Therefore, the glacial intervals, when the ice volume increases, it causes the oceans to get enriched in the delta 18O, and at that time the benthic foraminiferal test, they show higher values, so it is the correct option. During glacial intervals, delta 18 of benthic foraminifera shows lower values. No, just now we discussed in option 1 that it will show higher values, so this is not correct and this will be the correct answer. What about the third one? During interglacial interval, salinity of ocean decreases as compared to glacial. Of course, it will decrease because when the glacial interval is there, it locks the ocean water as ice and rejects salt. As a result, the salinity of the glacial ocean increases, and during interglacial, when the ice melts, the fresh water comes into the ocean. It is dumped into the ocean by melting of the ice, and therefore the uh, salinity decreases. During glacial intervals, the delta 18O record of ice core shows lower values. Of course, it will show because uh, when the precipitation at poles happens, the water which falls down as ice, it is completely depleted in O18, the heavier isotope. As a result, the ice core, it shows lowered values. I hope you understood this. One of the important consequences of northward movement of Australia in Cenozoic is establishment of Peru current and coastal upwelling, establishment of Western Pacific warm pool and Walker circulation, establishment of East Australian current, establishment of South Equatorial current. The correct answer would be second, establishment of Western Pacific warm pool and Walker circulation. So what it is asking about the northward movement of Australia in Cenozoic. So this northward movement of Australia, it led to the formation of the Indonesian archipelago or Indonesian islands, which act as the choke point in the transfer of water from Pacific to Indian Ocean. As a result, Western Pacific warm pool was formed. Due to the formation of Western Pacific whirlpool, the temperature of the Western Pacific became abnormally high. As a result, it led to the formation of another circulation cell typically in the Pacific, which is called as the Walker circulation. I have discussed about it in my videos in the uh, about El Nino. So if you want clarification on this, you can post in the comment section. Last question for today. Which of the following events have contributed to establishment of permanent ice sheet of Antarctica? Closing of Central American Seaway, closing of Indonesian Seaway, opening of Drake Passage, closing of Strait of Gibraltar, closing of Central American Seaway. It led to the Northern Hemisphere glaciation. Closing of Indonesian Seaway, it led to the stop of Indonesian through flow. Strait of Gibraltar, it has nothing to do with Antarctica, rather Strait of Gibraltar led to Messinian salinity crisis, while the opening of Drake Passage caused the formation of ice sheet or Antarctica. Let us see how the opening of Drake Passage led to the formation of permanent Antarctic ice sheet. So where is the Drake Passage rather? So if you look at the map of South America and Antarctica, this passage, it is called as the Drake Passage. We all know that Antarctica and South America were once joined together because they both were part of Gondwana land. So this was the scenario some few million years back, like this. So when this was the case, then the ocean water could not pass here. It got diverted. Okay. Now this breakage happened due to the stretching between these two continents. South America went northward, Antarctica went on moving southward. As a result, the Drake Passage opened and this water came in, started to encircle Antarctica. It, kind of made Antarctica an island continent. Now, this water which was encircling Antarctica, it is known as the Antarctic Circumpolar Current. At the same time, Antarctica was constantly shifting towards the pole that led to the cooling down of the temperatures, because this current which was encircling, it became colder. And remember, you should keep it in mind that the Antarctic continent, it received huge amount of rainfall during its journey towards the poles. Okay, during its journey toward the South Pole, huge amount of rainfall was there. Why do you think, where does this ice come from? It came from the same moisture which was there on Antarctica. So as Antarctica was moving towards South Pole, this current, the Antarctic Circumpolar Current, it became a colder current. Since this current was encircling Antarctica, it did not allow the warm water from the equator and tropical areas to come to the Antarctic coast. As a result, Antarctica became thermally isolated, and therefore it became a cold continent. So the correct answer would be the opening of Drake Passage. Alright guys, give a thumbs up if you like the video, and if you want more such lectures, do write in the comment section. I shall come back to you with more such videos. Not only the request to make more videos, rather you can also write your difficulties or the questions, or you can discuss anything pertaining to these questions on earth sciences in the comment section. uh, if you wish to add more topics to it, we shall try, but first of all, to focus on these fields of general geology, geomorphology, sedimentology, oceanography, micropaleontology, and climatology. All right, have an awesome day.